So this topic is about multiplication of matrices. If you want to multiply two matrices, you must know or you must check the compatibility between the two matrices for multiplication. So for checking the compatibility, there is just one rule. Two matrices can be multiplied only when number of columns of the first matrix is equal to the number of rows of the second matrix. All square matrices are compatible for multiplication because their orders matches. All square matrices of the same order can be multiplied without checking the compatibility rule. So if you have two square matrices of the order 2 by 2, then they can be multiplied very easily. But if the matrices do not have same order, if they are not square matrices or if they do not have same order, then you must check the rule of compatibility, which says number of columns of the matrix A must be equal to number of rows of matrix B. So this is the compatibility rule which you must check. Now after checking the compatibility rule, let us see one more thing. Suppose matrix A has an order of m by n and matrix B has an order of n by p. Can they be multiplied? Can matrix A get multiplied with matrix B? Let's check. What is the number of columns here? N. So always when you write a matrix like this, A m cross n or A m by n, m denotes the number of rows and n denotes the number of columns, right? So number of columns in the first matrix is n. In the second matrix B, what is the number of rows? It is also n. And number of columns p. So we can say that number of columns of matrix A is equal to number of rows of matrix B. Therefore, matrix A multiplied by matrix B is possible. A and B matrices are compatible for multiplication. A multiplied with B is possible. Now the question is, what will be the answer? If you multiply these two matrices, you will definitely get a third matrix. Let's suppose that third matrix is C, that is the product of matrix A and B is C. But what will be the order of C? Now the order of C can also be predetermined, can also be found before you multiply. Before you actually multiply, you can know the order of multiplication of order of the product of two matrices. So as I told you, here the number of columns are n, here the number of columns are n, so they can be multiplied. But whatever answer we are going to get here, let's say answer we are going to get is C. What will be the number of rows of C? So the number of rows of C will be m and number of columns will be p. So what will be the order of matrix C? What will be the order of the product of A and B? M by p. That is number of rows of first matrix and the number of columns of second matrix will give you the order of the product, right? So this two must be equal, then this is possible, right? So the order of the product is number of rows of first matrix multiplied by number of columns of second matrix. This is the order of the answer. So these are some very important things which you must know before you start multiplication. Let's take an example of multiplication of matrices. Now here, for simplicity, we have got two square matrices of order 2 by 2. We will multiply matrix A and B with the rules of how to multiply. You will understand with the method which I am going to follow, and we will verify the answer. Alright, let's start. So first, for the multiplication to begin, let's write A multiplied by B is equal to. Okay, so what we are going to do is, first we are going to multiply the first row with the first column, and then with the first row with the second column, then the second row with the first column, and the second row with the second column. I know that the order over here is 2 by 2 and here is also 2 by 2, so the order of answer will also be 2 by 2. So I want 4 elements over here, that I already know. So remember this, first you will multiply the whole first row with the first column. How to do that? So 1 into 4, 1 into 4, put it in bracket, plus bracket 2 into 3, 2 into 3, right? So 1 into 4 plus 2 into 3, this gives you the first element of the product. Similarly, now you will multiply first row with the second column. First row with the second column will give you second element of the first row in the product. So 1 into minus 1 plus 2 into 7, right? So we have got the first element of the first row of the product, second element of the first row of the product, by multiplying the first row of the first matrix with the first column and then the second column respectively. Now we'll multiply the second row with the first column. So we'll get 3 into 4 plus 4 into 3. Now second row with the second column, 3 into minus 1 plus 4 into 7. Let's see what is the answer. 4 ones are 4 plus 2 threes are 6. 4 plus 6 is 10. 1 into minus 1 minus 1 and 2 into 7 is 14. 14 minus 1 is 13. 3 fours are 12. 3 fours are 12. 12 plus 12 is 24. 3 into minus 1 minus 3. 4 into 7, 28. 28 minus 3 is 25. So the product of A and B is 10, 13, 24, 25. This is the method of multiplication. You must go through it again and understand how do we multiply. Right? Now with this, I'll just share a few laws of multiplication of matrices. Laws of multiplication Laws of multiplication of matrices. The first law is AB is never equal to BA. So multiplication of matrices is not commutative. You cannot multiply two matrices in any order. So A into B will not be equal to B into A in case of matrices. Multiplication is not associative. Okay, so this is multiplicative identity of 0. So 0 is null matrix. If you multiply a null matrix with any matrix, you will always get a null matrix. If you multiply a matrix by its inverse, if you multiply a matrix with its inverse or by its inverse, you will get an identity matrix. An identity matrix is which matrix? It is a square matrix with leading diagonal as unity. If A B is equal to A C, B may or may not be equal to C. B may or may not be equal to C. So you cannot cut A from both the side and say B is equal to C. B can be equal to C, B cannot be equal to C. It depends. A matrix into identity matrix of the same order will give you the same matrix. So this is the multiplicative identity. Okay, let us multiply matrix A and B and check what is the answer. As you can see, both matrix A and B are non-zero matrices, and you can pause the video and multiply these two matrices by the method which I showed you here and check the answer. I will also solve it. You can pause and start. I will start right away. Okay, so A B. So as I told you, in multiplication you first multiply the first row with the first column. So minus 3 into 4 plus 3 into 4. Then the first row with the second column. Minus 3 into 6 plus 3 into 6. Then the second row with the first column. 2 into 4 plus minus 2 into 4. Then the second row with second column. 2 into 6 plus minus 2 into 6. Minus 3 into 4 is minus 12 plus 12 minus 18 plus 18, 8 minus 8, and here it will be 12 minus 12. So this will give you 0 0 0 0. It's a null matrix. So none of the matrix over here were 0 or null matrix. Still their product is a null matrix. So it is not necessary for one of the matrix to be a null matrix for the product to be a null matrix. So that's one of most important identities of matrices. Okay, let's do one more example over here. Matrix A is 2 minus 1 minus 1 3. You have to evaluate a square minus 3a plus 2i, where I is a unit matrix of order 2. Now what is a unit matrix of order 2? Let's first find that out. A unit matrix of order 2, that is I 2 by 2, is nothing but a square matrix in which the leading diagonal is 1. So 1 0 0 1. All the elements except the leading diagonals are unity. Unity means 1. So you have to find the value of a square minus 3a plus 2i. Let's do it all separately. First we will find the value of a square. A square is a multiplied by a, that is 2 minus 1 3 multiplied by 2 minus 1 3. Now you know the process for multiplication of matrices. You can find the answer by pausing the video. I will solve it here. So I will get first row into first column, 2 into 2 plus minus 1 into minus 1. I will write it here. This is a very small space. 2 into 2 plus minus 1 into minus 1. Then first row, second column, 2 into minus 1 plus minus 1 into 3. Then second row, first column, minus 1 into 2 plus minus 1 into 2 plus 3 into minus 1. Second row, second column, minus 1 into minus 1 plus 3 into 3. Two twos are 4 plus 1 5. 2 into minus 1 minus 2 plus minus 3. Minus 2 plus minus 3 is minus 2 minus 3 minus 5. Then comes minus 2 plus minus 3 is minus 5 again, and here it is 3 3s are 9. 9 plus 1 10. So 5 minus 5 minus 5 10. This is just the value of a square. Now we have to find the value of 3a. Okay. Let's find the value of 3a. So 3a is 3 multiplied by the matrix A, that is 2 minus 1 minus 1 3, which is 3 into 2 6 minus 3 minus 3 9. This is 3a, and we have to find 2i. 2i is 2 multiplied by identity matrix 1 0 0 1, which will give you 2 0 0 2. Now you have to find a square minus 3a plus 2i. So what is a square? The value of a square was 5 minus 5 minus 5 10 minus 3a. 3a is 6 minus 3 minus 3 9, and the value of plus 2i is plus 2 0 0 2. First we will subtract the first and second matrices. 5 minus 6 minus 5 minus minus 3 minus 5 minus minus 3 again, and 10 minus 9, and then we'll add it to 2 0 0 2. So 5 minus 6 is minus 1, minus 5 plus 3 is minus 2, minus 5 plus 3 again minus 2, and 10 minus 9 is 1. Let's add this. So minus 1 plus 2 is 1, minus 2 plus 0 is minus 2, minus 2 plus 0 is minus 2, 1 plus 2 is 3, 1 minus 2 minus 2 3. That is the answer. So you might have solved and checked it. So if the answer is coming correct, that means you know how to multiply. You know how to multiply two matrices, a scalar with a matrix, and addition and subtraction of matrices. Okay. Next question. Matrix A is 3 5 4 minus 2, and matrix B is 2 and 4. Is AB, the product AB, possible? If it is possible, then we have to find AB. So let's check the order of A. The order of A is 2 by 2. The order of B, 2 rows and 1 column, so 2 by 1. What is the number of columns in the first matrix? 2. What is the number of rows in the second matrix? 2. And we know that if the number of columns of the first matrix is equal to the number of rows of the second matrix, then they both can be multiplied. So how will multiply? Let's see. Acha, before we multiply, can we know the order of the product? See, the order of A is 2 by 2 multiplied by order of B is 2 by 1. Can you tell me what will be the order of C, that is the product? The product will have the number of rows equal to the number of rows of the first matrix, and the number of columns equal to the number of columns of the second matrix. So this 2 comes over here, this 1 comes over here, and compatibility of these two should match. These two should be equal. So we know that the product of the answer, the order of the answer should be 2 by 1. 2 by 1 means it should look like a column matrix. Column matrix means like this. There should be just one column, right? So AB is possible, definitely. AB is possible. Let's find it. So AB is equal to, okay, so how we will do it? See, we are going to multiply the first row with the first column. First row multiplied by first column will give you the first element of the first column in the answer. In the answer there is just one column, so the first element of the first one column will be getting over here, and when we'll multiply the second row with the first column, we'll get the second element of the column. Okay, so let's do it. 3 into 2 plus 5 into 4. 3 into 2 plus 5 into 4. Okay, let's do the second one. 4 into 2 plus minus 2 into 4. So that's it. 3 2s are 6 plus 5 4s are 20, 26. 4 2s are 8 plus 4 into minus 2 is minus 8. If you add them, you will get 0. So the answer is 26 and 0. 26, 0. This is the answer, and AB is possible. Also, for matrices, you should note that the algebraic identities like a plus b the whole square is equal to a square plus 2ab plus b square is not valid. Algebra cannot be applied into matrices, like a square minus b square will not be equal to a plus b into a minus b. Algebra does not apply in matrices. So for matrices, algebra is not applicable. Algebraic identities are not applicable. Okay, let's do one more question. Okay, so the next question is, there are two matrices. One is a square matrix of order 2 by 2, 3 minus 8 9 4, and the second matrix is a column matrix of the order 2 by 1, and the answer is minus 2 8. That is also in the same order. So this is of the order 2 by 2, this is of the order 2 by 1, this is also of the order 2 by 1. You have to find the values of x and y, right? So to find x and y, we have to perform multiplication. Let's perform multiplication on the left hand side and equate it with the right hand side. So this will give you first row into first column. So 3 into x plus minus 8 into y, and second row first column will give you the second element, 9 into x plus 4 into y. You will equate it with minus 2 8. So this will become 3x minus 8y, and here it will be 9x plus 4y. You will equate it with minus 2 and 8. So as you know that these two matrices are column matrices with order 2 by 1, so you can equate their respective elements. Therefore 3x minus 8y is equal to minus 2, and 9x plus 4y is equal to 8. This is equation number 1. Equation number 2. Now you definitely know how to solve simultaneous linear equations, right? So you must solve these two equations and find the answer. Let's you can pause the video and solve it. I will solve it, and then we can check our answer. Let's solve this. So let's multiply equation 2 by 2. So what will we get? We will get 18x plus 8y is equal to 60, and this is your equation number 3, right? This is your equation number 3. So what we will do now, we will add equation 1 and 3. So this is elimination by equating coefficients, the method you've learned in class 9th. So 3x minus 8y is equal to minus 2 plus 18x plus 8y is equal to 16. So when we add them, what we will get? Here we are going to get 21x, this will get cut, and this will be 16 minus 2, 14. So x will be 14 by 21, 7 2s are 7 3s are 2 by 3. So putting x is equal to 2 by 3 in equation 1, 3 into 2 by 3 minus 8y is equal to minus 2. This will get cut. Minus 8y is equal to minus 2 minus 2 minus 8y is equal to minus 4. So y is equal to minus 4 by minus 8, and that is 1 by 2. X 2 by 3 and y 1 by 2. So if you have solved it properly, you should get the same answer. Okay, y is coming to be minus 2 by 8 or minus 1 by 4. My x is correct, that is 2 by 3. Let me check my y. If I put the value of x in equation number 1, it is 3 into 2 by 3 minus 8y is equal to minus 2. So 2 will go that side, become minus. So minus 2 is minus 4. So 4 by 8 is 1 by 2. It is correct. It is absolutely correct. Right? So this is x and y. Okay, we'll take one more last question, and then I think we are done with the whole chapter. Let's take one more question over here. Find matrix M such that M multiplied by 3, 6, minus 2, minus 8 will give you minus 2, 16. Okay, so let's see how to do this. So we have to find an unknown matrix A. Let's apply the rule of compatibility. Matrix M, we don't know its order. Let's take its order as P by Q multiplied by this matrix. Let's denote it by A. Its order is 2 by 2, and this is the answer. Let it be B. And the order of this answer is, so there is 1 row and 2 column, so 1 by 2. So if you see over here, if this multiplication is possible, the compatibility can only be achieved if the number of columns over here is equal to the number of rows. So we know that Q is equal to 2. Also, the number of rows becomes the number of rows in the answer, and the number of column becomes the number of column in the answer over here, right? So this is the compatibility and identifying the order of the unknown matrix with the rules. So we come to know that P is equal to 1. So therefore the order of the unknown matrix N is nothing but 1 by 2. 1 by 2 is like this. This is how that unknown matrix will look like. So let that unknown matrix M be A, B. Yeah, so that's an order of 1 by 2. Now write it in the multiplication form. So you will get A, B multiplied by 3, 6, minus 2 minus 8, you will get minus 2 16. Right now I think you know how to multiply, so you can multiply and check the answer by pausing the video. I will solve it over here. So we will multiply the first row with the first column and the first row with the second column. So we'll get two elements like this. So a into 3 plus b into minus 2, a into 3 plus b into minus 2, and here we will get a into 6 plus b into minus 8, a into 6 plus b into minus 8, and this is the multiplication on left hand side, which is equal to minus 2 16 on the right hand side. So let us simplify this. This will become 3a minus 2b, and this will become 6a minus 8b, which is equal to minus 2 16. And therefore equating, because these two are equal matrices, so 3a minus 2b is equal to minus 2, equation number 1, and 6a minus 8b is equal to 16, equation number 2. So if you solve these two equations, simultaneous linear equation, you should be able to find the values of a and b, which will give you the unknown matrix, right? So that unknown matrix comes out to be minus 4 minus 5. Please check your answer after solving it. So these are all the important questions of the chapter Matrices. There are many more other questions, but for now we are going to solve only these, and you can solve all the exercises of this chapter by watching these videos, and if you have any doubts you can message me. I will solve and I will explain the solution to you. Okay, see you next time.